Hi everyone, this is Simon from RevitUni.com, and today I would like to address the issue of spiral stairs in Revit. I don't know if you are aware of that, but spiral stairs in Revit actually don't work the way they should. So I will explain it to you at the beginning why, and if you were looking for the solution already, you probably are aware of that. So without further ado, let's jump into today's topic, and remember to leave a thumbs up if you like what I'm doing and subscribe to my channel. Let's start this tutorial by examining the existing stair tool in Revit and why I think it's a wrong way of modeling. So if I go to stair, I will be using assembled stairs. Let's select private, and here I have something that is full step spiral. It's very easy. I have distance between two levels, and now I start modeling. Let's make it a full circle. So I'm trying to push it as close as possible. Okay. And click accept. I will go to 3D view, delete the railing, and now I will remove some of the elements so we clearly see the steps of the stairs. I don't need sides, so supports would be changed to none. Click apply, and when I go to run type definition, I will uncheck risers. Okay, this is how every tutorial on YouTube starts regarding the topic of spiral stairs, but here's where I have a problem with it. So when you look at the top, those stairs, every riser starts when the one before it ends. So if I look at from the sides, you see that if I would draw a line, maybe I will go to north elevation instead, draw a detail line. I'm ignoring the nosing of the stairs, but you see that the next step is where the other step before it ends. So this is now how the spiral stairs work. Look at those pictures. If you take a closer look, you see that those steps are actually overlapping. It makes sense because spiral stairs are usually in a place where you don't have enough space for a normal stairs. So they need to be as condensed as possible, and that allows us also to have less steps and enough head space. So if I'm on the step third, I'm not hitting my head with the steps that it's above me. Those kind of problems we will have with stairs that are proposed by Revit. I have also a few other pictures. We can take a look also at them. They are very similar. You see, we have a column in the middle, and then they are running around it. The third pictures I have, it's also, you see, very small space. Okay, I'm not able to achieve it with this tool, so I will delete the stairs and actually will make it using railing. I know there are some tutorials about it already, but they are not addressing the full picture of full stairs, spiral stairs, directly in Revit. So I will start by creating a component that will go into railing. But maybe first, actually, let's go to north elevation and make sure this is 3 meters instead of 4. And I will start by drawing a railing that will at least show us a direction in which we are trying to go. This is railing. Shape would be a circle of, let's say, 1,000, so it's an even number. Okay, 1,000 radius. And now it cannot be, of course, the full circle. I need to remove at least a small part out of it, because railing needs to have one line that is not like closed or continuous. So I will use a split element command and remove some small part. Okay, let's see how it looks like. I will show you step by step. This is how it looks like right now. but we of course want to make it sloped. We don't have any object like stairs to attach it to it, so we need to do some trick and thinking out of the box. I will go by drawing a line, and I will draw a very short line. It can be of 1 millimeter. That's the shortest line that I can draw in Revit. And now I will select this part and change it to flat, and the height would be 3 meters. Okay. Now the other part, the rounded part that will go, that will create the spiral stairs, would be sloped, and it can be by type. Okay, let's go to 3D view and see how it looks like right now. Okay, at least it's going upwards. You see this element of 1 millimeters. It's not visible because of its shortness. And now I need to modify some elements that go into this definition. Let's go to edit type, and here we have a rail structure. I'm sorry, baluster placement. I will remove the starting post by choosing none, corner post as well, and end post as well. I click apply. Nothing is visible because there's another window under it that needs to be applied as well, but it actually removed those corner post and etc. We don't have corners here, so it will be only end and beginning post. The next thing under baluster is that the base would be actually top rail element, and since its height is 1 meter and 10 centimeters, I will offset it downwards to such value. Top would be top rail element. Okay, that's a good value. I click apply, apply, apply. Okay, so at least it doesn't attach to the base level anymore. What's the family of this posts? Let's check that. It's called M baluster square. I will search for that and go to right click and edit. Okay, this is how it looks like. I can remove that as well, or maybe I will keep this voids for now. Let's see, maybe they will be useful. Width and height, it's not necessary anymore. So the only thing that I need to do right now is to, maybe I will actually delete those reference planes as well. The only thing that I need to do now is to create a component that will be actually this step. Okay, so it would be better to create it as a separate family. So I go to new family, generic model. We will go back to this baluster post in a minute, so it's still good that we modified that. And now I will create an extrusion. So let's imagine my spiral stairs would be 1000 in diameter. Okay. Okay. I will mirror that. Oh, okay, of course with copying. Mirror, copy active, okay. Okay, maybe apply some roundings. The design of the steps itself should be pretty easy. I will leave an opening for a column, so let's make it a 40. And that's it. I will go to front and apply the thickness of such thread. We can also do other stuff, maybe add some support. So I will go back to front and create another extrusion that will look something like that. We can also create some openings that will be a steel element, so we can play a little bit with it. Okay. Let's make it -5 and +5. So the total thickness would be 1 centimeter. Okay. We can apply some materials to it. Okay. And we can save that model as separate entity. Now I will load it to baluster square and place it here. It would be a good idea to save it under a different name. So I will go save as RU spiral baluster step. Okay. Of course, I will connect the materials that I just created, so it will be thread material. Oh, this is support actually. Okay, so this would be thread, and this would be support thread material. Okay. Let's test it in the project, how it will behave. So I'm taking smaller steps before I add other elements to it, like poles, for example. I will load it into the project. Okay. Now, because the name of the baluster changed, I need to adjust the baluster family here and make sure it's the one that I just created. So it's a baluster step. Probably there was some leftovers from the type names of the square one, but it's either this one on this or this type. It doesn't matter because it's no longer connected to the square shape. Okay, you see, it looks like pretty nice. Maybe the side of this one is on the wrong, it should be mirrored. So it's good that I tested it already. So let me go back quickly to our spiral step and make sure it's rotated like that and being pushed here. Okay. Let's see how it looks like. Okay, it looks pretty nice. You see, because the diameter of the staircase, of this railing to be precise, was exactly the same as the width of the step. When I go to top, it should create a perfect circle in the middle that I can fill with a column right now. So if I go to column, there's no column here that it's rounded. So let's go to insert, load Autodesk family and search for that circular column. Concrete columns is a detail item, so maybe I will go search for that step by step. It is not. Let's do HSS round column. I don't remember what was the diameter that I created. I think it was 40 millimeters, so it should be 8 centimeters diameter. Let's search for something that small, maybe this one. And I will go to column, vertical column, up to level 2 in height. Okay. How was it placed? Okay, so it should be from level 1 up to level 2 without any offset. Maybe offset would be, let's say, 50 centimeters. Okay, we are getting closer. It looks pretty nice. But now we have to think about the distances between those elements. If I go to north, now the distance here between the threads is 131, and on top we have uneven step of 1 and 9. This is a pretty complicated situation because we have a spiral shape, so we need to apply some math into it. And but first I will show you how we can modify the distance of those elements. So if I go to edit type and again baluster placement, we can adjust the distance from previous by going to, let's say, 500. I will delete some dimensions, of course they are no longer relative. You see, I'm changing the spacing of those objects. And now we have to think how to calculate the length of this railing. For that we need to know the formula for the spiral length. After doing some research online, I found this formula for calculation, and I can enter the height of the helix, which is 3 meters, right? Like the distance between our levels. And pitch, which is the number of like repeating circles, is also 3 meters because we have only one full turn. So this is the, if you have like more complicated many turns, you would have to enter the height of the one full circle. So diameter is the radius is 1000, so diameter should be 2 meters. Okay. Okay, I have an error where pitch cannot exceed height, but it's not exceeding, so I guess let's make it something like 2.99999. Okay, that's a good enough calculation, but I guess this this formula have one mistake, which is like it should be allowed to have 1 here, right? Which is a one helix. So my result would be 696 meters. Okay. Let's think now how many steps would I want to have here, and divided by the spiral length. I will open calculator and now divide 696 divided by 15. Okay, so my value would be 464. So I will apply this value here. Okay, apply, okay, apply. And also we have some settings about the justification, and I will select here spread pattern to field. And break pattern never, although I don't think it will apply anyway to this situation. So of course this part of the table doesn't worry us. Click OK. Okay, first 2 steps are even, and let's check the last one. Great, I was able to calculate it perfectly. Now I can count the number of steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and of course the distance is 14 plus 15. So it's, I was maybe telling it the wrong way. It's not the number of steps, but the number of risers, which is also correct. So if I would calculate it here, it would be something like detail line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm not quite sure why it's not 15, but I guess it's some more advanced math than I thought. Anyway, I was able to have equal distances, which is the most important part for me, and the number of stairs will like come out of it as a, in a way, byproduct, you might think. But let me think for a second why it's not 15. Maybe if I would say to beginning, it will become 15. No, it's not happening, so let's stick to this setting. 464. This one I can uncheck as well, although we don't have a stairs here. Anyway, I will leave it like that. If you have any idea, maybe you're better at math than me and you understand why it happened, let me know in the comment. That's an interesting task, so let me know if you have figured it out. But my goal is achieved. Now I can further develop the step family. So let's try to add maybe a pole into it. This is a step. I want to go to baluster step. Okay, let's go to left. Okay, maybe first go here and start to create extrusion. I can now add some pole. Go to front. Extend that to this line. Load it into the project. Okay. Okay, and now I can add also some horizontal bars. So I can go to edit, rail structure, insert, profile. Let's make it at 30 millimeters, offsetted by 500 millimeters. I click apply. Okay, and okay. If I go to baluster step properties of 20 millimeters, let's say, let's start to apply some support thread material. Let's make it steel. Okay, maybe iron, steel. Okay. Thread material, some lumber. And this is the spiral stairs. If we need an additional element like landing on top, we can do it using a floor command, or we can model it as a custom in-place component. It's up to you. I can also maybe adjust the display settings so we enjoy the view of the model that I just created. And this is how the real spiral stair should look like. One last thing before I finish the tutorial is to show you how we can adjust the height of the railing, because we haven't focused on that aspect at all. So remember, we were attaching this baluster to the top rail element, and top rail definition is under this section. We have to have this use top rail checkbox active, and the height is 1100 millimeters. If you want to modify the type, let's say change the profile of it to circular or elliptical, you can do it also here. Of course, be careful with the naming. You should always rename that. So elliptical 40. Okay, click apply, and now it's changed, right? If you would like to have a lower elevation, let's say 900 millimeters, remember to make sure that the offset of the baluster is also changed to 900 here.